Ever wanted to take a screenshot, but the device did not have that function? Or extract bitmaps from screens you could not access? Guess what? Now you can. My web utility, ScreenFromShot, makes this process very easy. As bare bones as it looks, the output often requires minimal corrections in post. Still, the development was anything but easy. Let me walk you through the process. First, I wanted my app to be multi-platform, which is why C#, endorsed by our teacher, was ruled out. For best accessibility, I chose to build the frontend with standard web technology. I knew that to reach acceptable performance, I wanted to employ something faster than JavaScript for processing, but I wanted the images to stay off any servers. The obvious choice for powerful web apps is WebAssembly, but Mozilla's WebAssembly Studio is down, and I could not figure out the hosting it. The WebAssembly add-on on VS Code failed to compile my code, and nobody had the same problems as me. Finally, I tried Emscripten, but then I had no way to quickly transfer data to from an HTML canvas. Somebody did figure it out and built an image processing library on top, but that didn't include any low-level pixel access. So I ditched WebAssembly and tried to get my hand on WebGL. I managed to figure out vertices and fragments, but then I couldn't get image import work. With WebGL not possible either, my burnout was well underway, so I reached for a last-ditch solution. I could not manipulate pixels with JavaScript fast enough, but what if I didn't have to? I could just abuse the browser's rendering capabilities and basically integrate all backend functions into the front-end app. Let's see what I mean. First, we start with a typical HTML file picker, with JS to check if the upload is a valid image. When positive, this will get the image's resolution and generate its URL, which will be referred to by the input and output previews. Other user inputs include 4 transformation corners and the output screen resolution, which will be used to define sampling mesh dimensions. Coordinates are fed into an equation solver, which produces the linear transformation matrix both forward and reverse. These get applied to the output view and mesh using CSS, and the browser does the rendering for me. I tried to make output zoom and export work with a JS screenshot library, but that didn't work at all, and my manual attempts to render the output to a canvas failed when the transform function only turned out to accept isometric coordinates. As such, the user has to screenshot the page themselves, and my code cannot even do basic processing such as convolutions or a threshold. In fact, many of the functional and quality of life features I had planned turned out to be impossible, and pretty much just a bare-bone application is left. Still, it is quite easy to use if you know the limitations, and I still got some cool use cases out of it, such as helping me extract fonts from train departure boards for scale model copies, exporting QR codes for high-quality printing, fixing janky nearest neighbor scaling. It has wide support for image formats, including animations. Unfortunately, lens or pincushion correction is out of reach for this system, and other challenges include panels that don't quite fit together and JPEG compression. If you want to try or improve this tool, or just get massively underwhelmed by someone's code quality, see the link in the video description.